Hi there. This is my 3-minute presentation, and I'm going to discuss about sparse diffusion models. And basically, the presentation is about accelerated diffusion large language models with the dynamic cache eviction. So as you refer to the slide I uploaded, you can see, right. The first step basically, I'm just trying to make it straight for diffusion models. Large language models, you basically it operates like a masked discrete Markov chain. So every time when you try to decode something, you can't actually efficiently use the KV cache, and also it sort of disrupt the token-wise dependency. So that's the challenge we're facing. Is diffusion large models often lacks in accuracy. It has inefficient use of KV cache, and we'll try to tackle that problem. So basically, one of the strategies that we use is called dynamic bidirectional cache eviction, which basically means that we're using KV cache from the both side of the thing. And also diffusion model is the bidirectional model, so you have to look at the both side of it. You have to take care of the prefill cache, the dual cache during the inference process. And another thing is called delayed bidirectional sparse caching, which means that every time when you try to include the KV cache, it doesn't have to be continuous. It can be, you can pick that position 1, 3, 5, anything in any order, as long as it works for you, as long as it actually computed the best attention score. And then that will be the most important KV cache. And you can use this strategy to filter out those KV cache that is not important. Yep. So, and actually the performance benchmark is just the throughput. We got a 10-fold higher based on the baseline, but for the current soda, which is 1.3 better than that. And actually for inference reduction, we're measuring that with flops. For people who might not know what the flop is basically the number of floating point operations that you've done per second. And we have 56% T-flops reduction, which is really great, and we have end-to-end speed up at approximately 1.53. Right, so that's my project's about. And as my personal background, I'm a Georgia Tech student. Right, I have skills in Triton, CUDA, PyTorch, and also hardware software code designs. And right now I'm currently working on my new submissions on accelerated diffusion large model via finding bench consensus. Basically, we're running things in parallel and try to cross-verify to use this algorithm to really speed up the entire NFV stuff like that. Yeah. And more than that, I have projects related to PCBs, circuit designs, stuff like that. And one thing I realized recently that was really interesting is that we cannot actually use AI to solve the layout problem. It's a pure optimization problem. So I'm gonna say like people who are doing layouts, like circuit design stuff, they're not gonna be like studying the AI that much, but with the development of all those auto research agents, it's sort of gonna affect that a lot. But thanks for the presentations. And if you have any questions, just feel free to ask in the following chat box. And anything, if you just send me an email, that'd be great. Appreciate it.